All right, here's another review, consecutive integer problems, right? We've talked about this before last semester, but let's just remind ourselves. So if we have consecutive integers, if we let x be the first integer, then what would the next integer be? Like if the first integer was 2, what would come next? Right, 3, and then after that 4 and so forth, right? So basically with consecutive integers, we're just adding 1 every time, right? This would be the second integer. And then x plus 2 would be the third integer. And we could play this game forever, right? Okay, so forth and so on. Consecutive even integers. So now if we start with 2, the next even integer would be 4, right? So we're adding 2, and then the next one would be 6 and so forth, right? And we could even start at like 50. The next even integer after 50 would be 52. So no matter what, you're adding 2 every time. So if x is the first, then that means x plus 2 is going to be the second. And then x plus 4 will be the next one, right? The third, and so forth and so on. Okay? All right, now consecutive odd integers is tricky. A lot of people want to do like x plus 1, x plus 3, things like that. But how do you get from 1 to 3, or 51 to 53, or 57 to 59, or 1 million? Okay, just any number, right? Any odd number. Stumped myself there. I didn't have it right off the top. So if x is the first one, how do we get to the second odd integer? Yeah, we just add 2, right? From 1 to 3, 7 to 9, 11 to 13, etc. We just add 2 to get from one odd integer to the next. Okay, and then we'll add another 2, which gives us x plus 4 for the third. Okay, so even and odd integers, these are the same, right? These come out to be the same. All right, so let's see what we have in store with even and odd integers. So number 2, the product of two consecutive odd integers is 143. What are the integers? Okay, so the product of two consecutive odd integers. So let's say that the first consecutive odd integer is x, right? And then the second one is going to be x plus 2. Okay, and so it says the product. So what does product mean? Right, that's right, we multiply, right? So it's saying if I multiply this times this, I'm going to get this, right? So let's set that into equation. X multiplied by x plus 2, don't forget the parentheses, equals 143. Right? And then now we're back to something we've done before. We can distribute, get x squared plus 2x equals 143. Then we can subtract 143 from both sides because that's right, we want to set one side equal to 0. So we get x squared plus 2x minus 143 equals 0. Okay, so now that it's set equal to 0, now we can do some factoring. So we check for GCF, nothing there. And so then we set up our parentheses, we put an x here and an x here. It's just a simple quadratic. Nothing bigger than 1 in front of x squared. So then we're looking for numbers we can multiply to get 143 that we could subtract to get 2x, right? And so what are those numbers? So 143, I'm not too familiar with it, so I'm going to make a list. So I could start at 1 and 143. 2 doesn't go in because it's odd. 3 doesn't go in because it adds up to 8, and 3 doesn't go into 8. 4 doesn't go in because it's odd. 5 doesn't go in because it doesn't end in a 5 or 0. 6 is even. 7 doesn't work. Decimal. 8 doesn't work. Nope, because it's even. 9 doesn't work. 1 plus 4 plus 3 doesn't add up to a multiple of 9. 10 doesn't work because it doesn't end in a 0. 11 does work. 13 times. There we go. So 11 and 13, those are two numbers we can multiply to get 143 that we can subtract to get 2x. So we put the 11 in one set, 13 in the other. This tells us the sign of the bigger number. And when this is negative, the signs are different. Okay. So now we can go straight to the answer. X equals 11 and x equals 13. All right, let me know if you have any questions.